In this lesson, I'll provide a basic overview for looking at categorical data in SAS and generating some straightforward test statistics, particularly the chi-square test statistic, and also some basic measures of association, odds ratios and risk ratios. So the objectives are to understand how to do these things using proc-freq, specifically using proc-freq for contingency tables. You should be able to interpret your results from a contingency table from the standpoint of understanding how SAS is presenting it to you. And you should understand how to use proc-freq to generate chi-square statistics, odds ratios, and risk ratios. So very briefly, as a reminder, the chi-square statistic is a very common test statistic used for categorical data analyses. And we'll use a few basic examples in this lesson thinking about socioeconomic status and smoking, whether or not the two are related to one another. And the core concept underlying the chi-square is the calculation is based on some comparison of expected versus observed values in a data set. So for example, here's a pseudo data set summarized in the slides. I'm only presenting the actual frequencies of individuals, and I'm cross-tabulating smoking status in the rows against socioeconomic status in the columns. So you can see there are 10 individuals who are of high SES who report never smoking. There are 8 individuals of middle SES who report never smoking, and so on and so forth. These are the observed data. Now, if we were to generate a table of the expected values, which we very rarely, if ever, do by hand, SAS will do this for us, we could think about comparing the observed and the expected results. And by doing that comparison, you can use standard formulas to then calculate a chi-square. In this case, the chi-square is 3.64. Combine that with degrees of freedom and look at a chi-square distribution, and you can generate a p-value, or what are the probability of observing the observed data if in fact the null hypothesis of no relationship between socioeconomic status and smoking is in fact true. So this is a summary of one basic form of a chi-square, looking at difference between observed and expected counts. The expected count information, or the formula for generating it, is just specified here. It's simply the product of the row versus column marginals divided by the total sample size. So for example, if you took 21 times 23 and divided by 61, you would get a value of 8. This is just the previous slide. And then a quick note about how to get degrees of freedom from contingency tables. They're defined by the product of the number of rows minus 1 times the number of columns minus 1. So again, going back one slide, we have 3 rows and 3 columns, so the number of degrees of freedom would simply be 2 times 2, which is 4. And this is a quick visualization of various chi-square distributions, and the distribution depends on the degrees of freedom, or in other words, the number of rows and columns in your contingency table. So let's jump into an example in SAS. In the editor file for this lesson, there's some code that will read data into a new data set called smoke, and then we can look at a cross-tabulation between a variable named SES and a variable named smoke. And you've seen proc-freq before. You're familiar with table statements. As a reminder, if you want to generate a cross-tabulation table, you simply need to use an asterisk to connect the two variables that you want to form your rows and columns of the table. And the new piece of information here is our request for the chi-square statistics, the default chi-square statistics that SAS will provide. And you can request that using the CHI-SQ option. As with many options within SAS procedures, the option here is specified in the table statement, and it comes after the /. Here's the editor file, and at the beginning of the editor file is simply a data step that will read in some made-up data inline based on the information I've provided here in the data lines. This is creating a new output SAS dataset that will be temporary, work.smoke. Again, I don't need the work because it's implied if it's not specified explicitly. And the input data are actually coming from a non-SAS source. I'm just inputting them directly from an editor file. So if you simply highlight all of this code down to the run statement and submit it, see that we have dataset work.smoke. It has 42 observations and 3 variables. Those variables are ID number, smoke, and SES. And now we can use a proc freak. In the table statement, ask for a cross-tabulation of SES by smoking status, the SES and smoke variables, and then use the CHISQ, short for chi-square, option to the table statement. But recall, if you're typing this in on your own, which is advisable to do as practice, you do need a / separating the cross-tabulations requested in the table statement and the chi-square option. You can highlight that, submit, and here are the results. Right? So let's first talk about the actual table and how to interpret the values provided in the table. Each cell in this table has 4 different numbers. So I'm going to talk about the numbers corresponding to the current smokers of high SES, this upper left-hand cell. We have the numbers 2, 4.76, 15.38, and 14.29. And the meaning of these values is specified in the upper left-hand corner of the table where the legend is located. So the first number simply corresponds to the frequency. In other words, there are 2 individuals in this data set who are current smokers of high SES. The second number corresponds to the percent, and that is the percent of individuals in this cell out of the total number of individuals in the table. In other words, there are 4.76% of all the individuals in this table are current smokers of high SES, or in other words, 2 out of 42. The third number in the table corresponds to the row percent, and this is simply a percentage that's conditional on being in a particular row, or in the current row. So here we're talking about the row of individuals that corresponds to high SES. There are 13 of those individuals, and this is telling us that 15% of all 13 high SES individuals are current smokers. And then the column percent just switches the condition. Now it's talking about percentage of individuals who are of high SES conditional on being a current smoker. So in other words, the denominator for that calculation is this 14 current smokers. 14% of them are of high SES. And down below you can see that there are some default statistics that are output by SAS, and these statistics down here are the result of the CHISQ option we specified in the table statement. In other words, specifying this option gave us this output. And it gives you a number of different statistics by default. Usually of highest relevance are the chi-square statistics in the table, where you get the degrees of freedom, the actual value for the chi-square value, and the p-value associated with that value. So this prob column corresponds to p-value. And I provided a quick definition for some of these chi-squares and their meaning in the slides. The first chi-square value that's output in SAS as a default has just the basic label chi-square, and this is simply a standard Pearson chi-square statistic that involves the differences between the observed and expected frequencies in a row by column table. And in most settings, at least within the context of this course, this test statistic would be appropriate. You also get a likelihood ratio chi-square statistic, and this simply involves ratios between observed and expected frequencies. So a similar but related chi-square value. And you also get by default Mantel-Hansel chi-squares. This particular chi-square tests the alternative hypothesis that there's a linear association between the row variable and the column variable. It would be appropriate to interpret this variable in situations where both the exposure and the outcome, or at least the two variables that you're cross-tabulating, lie on an ordinal scale. For example, in the context of our obesity and hypertension questions, you could imagine a three-level variable based on BMI for normal, overweight, and obese, and maybe a two-level outcome, or even a three-level outcome for hypertension, corresponding to something that might be defined as normal, maybe intermediate risk, or hypertension as the outcome. And the concept is that both of those variables are defined such that higher levels of the variable mean higher levels of exposure and worse outcomes. This is, again, just another summary of the values that are presented within the context of a row by column table or a contingency table using proc-freq, and we discussed that in the context of the SAS output, and it's defined here again for you. You can also use proc-freq to generate odds ratios and risk ratios, but unfortunately SAS will only generate these summary measures of association in the context of 2x2 tables. So that may mean that for many variables you need to do some further operationalization within a data step to get your exposure and your outcome defined into two levels if you want to use a tabular analysis and get a basic odds ratio or risk ratio. This code in the slide demonstrates a data step where we're creating a new SAS output data set named SMOKE2. It's a temporary SAS data set because we're implying that it's the work data library. We're starting from an input data set using the set statement named work.smoke, and then we're simply using some if-then statements to reoperationalize the smoke variable into a new variable named eversmoke, and that's simply going to be defined as eversmoke equals 1 if smoke is equal to current or former. And if smoke is equal to never, then eversmoke will be 0. And similarly, we will also create a new variable named low SES right here. That's defined as being equal to 1 if the original SES variable is equal to low. And it's defined as 0 if the original SES variable is equal to middle or high. You'll also note that in this framework, whenever you are specifying values of a variable that are character in nature, so words, for example, you need to include them in quotation marks, but that is not true when you're defining or referring to values for a variable that are numeric. In this example, we were creating a new variable with numeric values, zeros and ones, based on values of existing variables that were character in nature, current, former, never smokers, and then low, middle, and high values for SES. Then once you have that operationalized within a data step, the next approach, or the next thing that you would need to do, is sort the data set by descending order according to values of the two variables that you want to cross-tabulate. In other words, we want to sort this data set SMOKE2 according to the low SES variable and the ever smoking variable, and I want it sorted in descending order. So essentially the values of 1 will come first in the data set. And then you can run a proc-freq on that new sorted data set. And you can see up here that I output the sorted data set to a new SAS data set named SMOKE3, which means down below I need to specify SMOKE3 as the data set to run the frequency procedure on. And then you should specify the order equal data option. This is a new option that we haven't discussed yet. And in the table statement, you can request the CMH1 option. So the CMH1 option will request various additional statistics, which includes odds ratios and relative risks. And the order equal data option simply tells SAS how to correctly create the 2x2 table so that the odds ratios and risk ratios are calculated correctly. Go into SAS and take a look at that. Here's the data step where I'm reoperationalizing the data, creating my two new variables. That ran without any problems, so now you can see instead of 3 variables we have 5 in this new dataset SMOKE2 because we created 2 additional variables. Then I'm going to sort SMOKE2. I'm going to output the new sorted data into a dataset called SMOKE3, and I want to sort by low SES and ever smoke. That worked fine. And then finally we can run the proc-freq. And in this proc-freq, within the table statement, I'm going to request some chi-square statistics and also the CMH1 option, which will give us odds ratios and risk ratios and a few other default statistics that come with that specific option. So again, a reminder that you can often request multiple options to statements. And I'm also going to run a proc-print after that proc-freq, simply to show you the structure of that new sorted data set. In other words, what does the data set look like after it's sorted by descending values of low SES and ever SMK? And since SAS usually brings you to the very end of the output you requested, that means the first thing we see in the output window is the proc-print results. I'll just start by quickly summarizing that. And the point here is that I requested that SAS print out the variables low SES and ever smoke, and since we had sorted the data set, you can see that all of the values of 1 are coming first because we specified it should be sorted in descending order. Okay. This is important because based on the order equal data option in the proc-freq statement, what we were telling SAS to do was to create the rows and columns in our 2x2 table according to the order in which it encountered certain values in the data set. So all you need to know here is that after sorting, the values of 1 for low SES and ever SMK came first in the data set, and then SAS used that information to make the 2x2 table. Well, let's take a look at the 2x2 table if we scroll to the beginning of this output. And as you can see, we have a 2x2 table where values of 1 are in the first row, values of 0 for low SES are in the second row, and for the ever SMK variable, values of 1 are in the first column, and values of 0 are in the second column. By default, SAS will create contingency tables according to ascending values of the variables. In other words, if we hadn't specified the order equal data option, we'd have 0 and 1 in the first and second rows, and we'd have values of 0 and 1 in the first and second column. But what we need is the reverse, because that's how SAS expects the data to be formatted when it's creating odds ratios and risk ratios. This gives us the basic 2x2 table, and you can think about various distributions and row percentages and column percentages, etc. that may be of interest to you. Something that's usually of immediate interest and directly related to the risk ratios we'll be looking at is to look at the row percentages, or in other words, the conditional probability of being a smoker if you have low SES. And we see here that 81% of low SES individuals are ever smokers, as compared to 58% of individuals who are not of low SES are ever smokers. Okay. So the 81 over 57 would actually give us our risk ratio if you wanted to compute it manually, we'll see down below in a moment that SAS will calculate that result for us directly. Before we scroll to the next page, just observe that you get your basic chi-square statistics here, and that is included again because we asked for the CHISQ option. And this is the output that that is generated because we requested the CMH1 option. So by default, you get a Cochran-Mantel-Hensel statistic, which is identical to the MHC statistic in the above chi-square information that was output. So this is a bit duplicative simply because this particular statistic is included as a part of different options in SAS. So you get that twice, and then here you get the odds ratios according to different methods. You get the actual value of the odds ratio. So here the odds ratio is 3.17, and 95% confidence limits are generated by default. And here's the risk ratio of interest. It's labeled in sort of a quirky way in SAS. They label it as cohort column 1 risk, and by that it simply means, if we go back up to the 2x2 table, it's considering the risk of being in the first column. So that means that you would want your outcome variable or your disease to be in columns, which is the standard in most 2x2 tables in epidemiology, and you want the diseased individuals to be in the first column. And as long as that is the case, this will give you a risk ratio that can be interpreted as is common in epidemiology. In other words, the risk of being an ever smoker among individuals with low SES is 1.4 times greater than the risk of being an ever smoker among individuals who are not of low SES. And you get, again, 95% confidence intervals. And then this final set of output here simply corresponds to the risk ratio for being in column 2. So you would have to be in column 2, and again that corresponds in this setting to risk of not being an ever smoker, which usually is not the question of interest, and in most situations this output here can be ignored. Now below, if we were to run, if we were to run this proc-freq without specifying the order equal data option, so you see here in the proc-freq statement, I don't have an order equal data option as I did up above in line 79. If we were to run that, this is how the 2x2 table is structured. So the difference here is that now values of 0 are in the first row and 1 are in the second row for the low SES variable, and for the ever SNK variable we have 0, 1 instead of 1, 0. Now the odds ratios end up being the same because of the nature of the formula for the odds ratio. I'll let you think about that a little bit, but you'll see that the risk ratio is different and incorrect because again it's looking at the risk of being in the first column among individuals in the first row, and then the risk of being in the first column among individuals being in the second row. And that's about the exact opposite of the risk ratio that we were interested in. So that's what happens if you don't have the order equal data. The 2x2 table is not set up properly, the calculation is not done correctly, and then you can get unexpected results. This is just summarizing some of the output from SAS when you use proc-freq and request the CMH1 option. We discussed that as we went through the output. And again, this is just reminding you using a different visual about how SAS is calculating odds ratios and risk ratios. When SAS calculates the odds ratios and risk ratios, and speaking sort of in general, from a general epidemiological framework, SAS is assuming you have your exposed individuals in the rows, and the exposed individual is in the first row specifically, unexposed in the second, and then SAS is assuming that the disease status variable will be in the columns, diseased individuals in the first column, non-diseased individuals in the second, and you can think of each cell as being labeled A, B, C, D, and then, as in most introductory epidemiology books, odds ratios are defined as AD over BC, and risk ratios would be defined as A over A plus B divided by C over C plus D. Okay. So it's important that the data are in this format in order for the odds ratios and risk ratios to be technically calculated correctly. As we saw, this is not how SAS structures the data in rows and columns using proc-freq by default. In order to get the table to be structured properly, first we had to order the data set by using a proc sort, and then we had to use the order equal data option within proc-freq. I've just specified all of this in the slides to make sure that it's clear. And we looked at this example in the SAS code where we ran the proc-freq on this data set without using the order equal data, and we saw that we got the incorrect risk ratio. Here's an alternative approach that may be more intuitive or a bit easier. This approach to getting the table structured correctly and therefore getting the correct risk ratios is done using formats and then by using the order equal formatted option within proc-freq. So in this example, first we have to run a proc format at some point in our code. We have to create the rules for the formats we want to use. I've created a format named exposed F, which corresponds to not exposed when the value of the variable is equal to 0, and exposed if the value of the variable is 1. I used a similar approach to create a format that I can apply to disease status. And then in the proc-freq, I specified order equal formatted, and then I applied these formats to my exposure and my outcome or my disease. In this situation, the outcome was being an ever smoker, yes or no. And then, no different than other proc-freqs, I specify the cross-tabulation I want in the table statement, and I'm requesting the CMH1 option here. Here's what it would look like in the SAS code. So we can highlight the proc format, submit that to SAS. Again, in the context of a proc format, we don't get any actual output. This is just creating a set of rules, and that is reflected in the log file. If you take a look at that, things ran correctly, and the new formats are then defined. And then I apply that format using a format statement within proc-freq, and I've also specified order equal format. So now instead of ones and zeros, it's just printing out the labels that I asked for according to the format rules. So now we see exposed and not exposed, and disease and no disease. Other than that, the 2x2 table is no different. And then we get the odds ratios and risk ratios and various test statistics that were requested. A quick note about how 2x2 tables or any sort of contingency table is structured in SAS when you use order equal formatted. It will put in the first row the format. It's essentially alphabetically, so it will use the format that starts with the lowest letter. Okay? So in this example, we had applied the exposed format to the low SES variable, and low SES is the first variable in our table statement, so that's going to be the rows in our 2x2 table. And since E for exposed comes before N in the word not, the exposed individuals will be in the first row and the not exposed in the second row. Okay? If you're ever in a situation where the actual words you want to use um, don't create the ordering that you need, you can always manipulate that a bit artificially. For example, we could just put an A in that format label and a B here to make sure that this is going to be seen by SAS as the first level of the variable, and therefore the level of the variable that should go in the first row, and then this would be the next level of the variable that would go in the next row, and so on and so forth. But as it turns out in this example, simply using exposed and not exposed works, and again, it's simply because E comes before N alphabetically. And the same is true for the format used for our disease variable. We created a format called disease F. 1 was equal to disease, 0 was equal to no disease, and D comes before N. So as a result, individuals who have a value of 1 or a label of disease will be in the first column of our 2x2 table, as we saw. Now if we wanted to move on and try this in a different context, you could go through and make various variables within these data sets that have been provided to you and try and do some basic analysis looking at the question of BMI and hypertension. So I'll do that briefly here. Much of this code you've already seen in previous lessons, merging together the various data sets. Just going to highlight all of that and submit it. Everything seems to have run all right. And I'll just specify that I did create 2 new variables at the end of this data step that are defined according to BMI levels. One variable is named overweight, and another variable is named obese. And we've previously seen this hypertension V3 variable. And then I can use proc-freq to cross-tabulate those variables. I'm going to use the formats that were previously created. So as a reminder, I don't need to rerun the proc format because SAS will remember the rules of that format for the duration of this SAS session. So I can just apply the disease F format to whatever my outcome variable is, which will be hypertension, V3. And then I can apply the exposed format to whatever my exposure variable will be. And I'm going to ask for 2 different 2x2 tables, one based on the overweight exposure and another based on the obese exposure. So I will apply the exposed format to both of those variables. And then I'm going to specify those 2 different tables in the table statement. So first we'll get a table corresponding to overweight cross-tabulated with hypertension V3. And then second we'll get obese cross-tabulated with hypertension V3. As options, I've asked for some chi-square statistics as well as the Cochran-Mental-Hensel statistics, or CMH1. Here's the first 2x2 table that cross-tabulates overweight status with hypertension. Here are the chi-square results. And here are the results from the CMH1 option. So for example, if we're interested in the risk ratio, we see that the risk of hypertension is 1.88 times higher among overweight individuals as compared to non-overweight individuals. And then the second 2x2 table looks at obesity, or the variable obese, cross-tabulated with hypertension. Again, we have chi-square values and p-values, so clearly these 2 variables are related to one another. And the risk ratio here, in the context of the obese variable, is 1.81. In other words, individuals who are defined as obese have 1.81 times the risk of hypertension relative to individuals who are defined as not obese, or overweight and normal weight. And then we have 95% confidence intervals as well. If you wanted to stratify by a 3rd variable, for example, to get some stratified or adjusted results to remove the potential effects of a confounder, you could simply add that third variable at the beginning of the cross-tabulation. So now this will give us sex times obese times hypertension V3, or in other words, we'll get results that look at the relationship between obesity and hypertension across levels of the variable sex. Before we can do that, though, I see I've specified that I want to include a format for the sex variable, and I haven't created the format in this session yet, so we either need to run a proc format to define this gender F format, or I could just delete this out and remove it. But to make it a bit more readable, let's quick run a proc format. And in this data set, values of 1 are equal to men, and 2 is equal to women. So this sets up the rules for that particular format, and then I need to add the name of the format. So we name that gender F. Okay. So the gender F format will print out men when values are 1 and women when values are 2. So I can highlight that as well as the proc freak and submit it all together. There are no problems there. Here are the results. So this is the relationship between obesity and hypertension among the men. Here are some chi-square results for that cross-tabulation. Here are the results among the women. And again, some chi-square statistics for that cross-tabulation. And the CMH1 information does not get provided for each gender-specific analysis or cross-tabulation. It gives you the overall result. So in effect, what you will get are adjusted odds ratios and risk ratios, and they're adjusted for gender in this example. So again, here are the odds ratios and the risk ratios, and an additional piece of output we haven't seen before. When you're stratifying by levels of a third variable, you also get a Breslow-Day test for homogeneity of the odds ratios. If you were thinking about interaction and you wanted to determine whether or not the odds ratio was similar among men and women, or different enough to suspect that there could be some effect modification or interaction, you could use this Breslow-Day test result in regard to that inference. We're not going to talk about effect modification within this particular course, so I'll mention it since it's a part of the default output. And for those of you that are interested in doing those types of things, you can pursue that a bit further and read up on Breslow-Day tests and using it within SAS. So the basic goal here was simply to get odds ratios and risk ratios according to gender stratified analyses. But again, a limitation in doing that was we couldn't actually see the odds ratios and risk ratios for ourselves by gender. If you wanted to do that, one approach would be to run the proc freak but use a by statement and just tell SAS that you want to see the results separately according to levels of the variable in the by statement. So here we're going to say by sex, and anytime you use a by statement in a SAS procedure, as we've discussed, or within a data step, first you need to make sure that the data set is sorted according to the level of that variable. So we'll start with the proc sort of the data set by the sex variable, and then we'll run the proc freak by the sex variable. Scroll to the top, and now again you see the results among men, no different than what we would have observed previously. You get some chi-square statistics, but here you also get the odds ratios and risk ratios among men. For example, the odds ratio regarding the relationship between obesity and hypertension is summarized here. Among the men, it's 3.4. And then if we scroll down to the odds ratio among women, we see it's 4.3. So there's some evidence that the odds ratio is stronger among women and men, and given this large sample size, that there was evidence of non-homogeneity according to the Breslow-Day test, as we saw in the previous analysis. But nevertheless, there's a positive relationship in both men and women. It may be stronger in women in this particular data set. This is just summarizing what we saw in the editor file. And I wanted to specify a couple of additional options that you could use that are sometimes helpful to make the tables that are output a bit more readable. So within the context of a table statement, you could specify the no column, the no row, the no freq, no percent, missing and list options. We've talked about what missing and list will do in previous lessons, and you could try the no call, no row options and see what you get with that. Provide a real quick example using the smoke data set. So again, this is a proc-freq cross-tabulating SES level with smoking status, and I'm asking for chi-square statistics, but I'm also specifying the no row option. And what that does is it simply suppresses the row percents. So I have the column percents, which is defined in the upper left-hand cell here, or in the upper left-hand corner in the legend. Column percents are still there, but the row percents are not, and that's because I specified the no row option. No row option was specified there. Alternatively, we could specify the no column option with no call. So now this third number in the cell corresponds to the row percents instead of the column percents. So in summary, now you should be able to use proc-freq within SAS to obtain some basic chi-square test statistics derived from contingency tables, and you should also be able to get some odds ratios and risk ratios. And remember that particularly for the risk ratio, to get the correct results, it will often be necessary to reorder your data set or to use formats, and then to also use an order equal option within proc-freq.